Hello guys and welcome back to AutoCAD tutorials. In today's session, we are going to see how to calculate shuttering quantity for beams. Slabs and columns will be taken later. So we have one IS code, IS 1200 part 5, which is used for measurement of shuttering. Okay, so here we have a simple example of a beam where we can see the basic how to calculate shuttering of beams. So here in this example, we have three beams, beam 1, beam 2 and beam 3, having depth as 700 mm and width as 230 mm. Each beam has same dimensions and length of each beams are of example 2 meters. So for shuttering, we will take three faces of this beam. The first face is this one, the second face is this bottom, and the third face is this inner side of the beam. We won't be considering this 200 mm depth since concrete will be filled in this complete area. So this side we don't have any kind of shuttering, so we won't consider this side in shuttering. So practically we have three sides, one of 700 mm, 230 mm and this 700 minus 200 which is 500 mm. For beam B2, again we have three sides, one underlying side, second is the bottom, and third one is again an underlying side. So here we have this side as 700 minus 200 which is 500 mm, bottom as 230 mm, and the third side as 700 minus depth of this slab is 100, so 700 minus 100 which is equal to 600 mm of the depth. Similarly beam 3, we have three sides, 700, 230 and again 600. So here in bottom we have shown the calculation for this. We have added all the three sides of the beam, that is the complete perimeter of the shuttering. Then we have multiplied this perimeter with 2, which is length of the beam, 2 meter. So we get quantity of shuttering for beam B1 as 2.86 square meter, for shuttering of beam B2 as 2.66 square meter, shuttering of beam B3 as 1.53 square meter. But this is very basic example, and we will see how to calculate complete shuttering quantity of beams in our Excel file related to practical example which we work on sites. So before proceeding to that, we will see some clause of IS 1200 which is used for deductions and measurement. So clause 6.4 states that no deduction shall be made for openings up to 0.4 meter square. For example, we have this slab and we have two openings in this. One opening is less than 0.4 square meter and the other opening is having more area more than 0.4 square meter. So this opening won't be deducted from the slab quantity, but this opening will be deducted from shuttering. So this is what clause 6.4 states. Now proceeding to further clause, which is highlighted in two different shades. These two different shades resembles two different kind of quantity. The first one is formwork to secondary beam shall be measured up to the sides of main beams, but no deduction shall be made from the formwork of the main beam where the secondary beam intersects it. What does it states that this is my secondary beam which is resting on my main beam. What here it is written that formwork to secondary beam shall be measured up to the sides of main beam. So this is my first side of the main beam. This is my second side of the main beam. So my secondary beam will be measured from this end to this end, and there will be no deductions made in the main beam shuttering for the width of the intersection of this secondary beam. Here we have complete running edge, but here we have two edge broken, one this and other one is this, but we won't deduct this shuttering from our main beam. This is what clause 6.6 specified. And the second one is formwork to beam shall be measured up to the sides of column. If we see our main beams, this and this main beam, this is measured up to the sides of column, means from this end to this end, from this end to this end, from this end to this end, and so on. But no deduction shall be made from the formwork to stanchion or column casings at intersection of beam. But in column shuttering, where this beam intersects, we don't have to deduct any area of formwork in column shuttering for the depth of beam which is intersecting in the column. This is what clause 6.6 specifies. So now let us move to our AutoCAD practical example where we can see how we can calculate the shuttering quantity using AutoCAD and Excel. So here I have kept open my plan. Here we will take example of simple beams. For example, beam B11, which is our main beam, which is running through column B12 to B18. Then we will be seeing our beam B75, which becomes an example of secondary beam, which runs from beam B11 to beam B3. And we will be taking one cantilever beam B52. We have two options. One is TrueView and the other one is AutoCAD. For working with beams, I would highly recommend you all to use TrueView since we can directly get measurement of beam from TrueView using this feature of quick dimensions. Now, in beam 11, I will be just placing my cursor and I will get our beam dimension as 5.079, which I will be taking as 5.080. Now, without leaving the command, I will place my cursor here. Again, I will get my beam length as 3.85. Without leaving the command, now I will again scroll my cursor here, then I will get this beam length as 2.449. So this is the benefit of TrueView, that you can directly get the length of the beam by just placing your cursor over the line. So now starting with our working, here is our B11 whose length is 5.080. I will be going to my beam shuttering, serial number 1, beam number 11. The type of beam is simply supported beam, so I won't specify anything here. For example, grade of our beam is M30, number of beam is 1, length which we have got here as 5.080. Now width and depth of the beam is given as 200 by 600, 0.2 and 0.6. Now here I have given option of slab. L means left, R means right, cant means cantilever. Now L means name of slab which is on the left hand side, name of slab which is on the right hand side, name of the slab which is on the cantilever side. Now here I have given slab depth. Now based upon the name of our slab depth will be defined. Why I have provided this kind of feature as when we see our drawing, we have only slab number specified in the drawing. We don't have our slab depth specified. So to get the slab depth, each time I have to refer my slab schedule. This will unnecessarily keep piling up my work of every time. See here S4, then go to slab schedule and check what is the depth of slab S4. So better what I have done is in Excel, I have made my slab schedule ready for the reference. Now again, not each time we will come and see over here what is the depth of S4, what is the depth of S3. We won't do that kind of working. Instead, we will use a formula known as Vlookup. Now how we will use that formula, we will see over here. Now in our beam B11, we have slab S4, S2, S5, lot of the slabs on each other side. So first, to take a basic example, we will take suppose slab S2. Okay. So I will be specifying slab S2 as here S2, and on the right side I have slab S3. So I will be specifying slab depth as S3. We don't have any cantilever side, so I will keep this as blank. Now here we will use our formula Vlookup. Vlookup, which value we have to look up is first left slab. So we will see S2, comma. Now we have to specify table array. So I will be selecting my table array from column CD till row number D12. So these two columns become my table array, and keep in mind this will act as column number 1, this will act as column number 2. We have specified our value from column number 1 already as slab S2, and now in column index number we will specify column number as 2 so that it can check the value of our slab depth S2. Now we will again give a comma and go for an exact match. Now close the bracket. Now it will give your slab depth as 0.1 meter. Now I will be freezing our table array so that by dragging our formula, these cells are freezed. Now I will just drag this formula here. So automatically I have got slab at right as 0.15, and if we will look at our slab schedule, slab S3 is having slab depth of 0.15. Now here on cantilever side, we are getting NA because nothing is specified here. So to avoid this kind of error, what we will do is we will input one more formula if error. If we encounter any kind of error or we don't have any kind of value over there, so what we will do is we will take value of that slab only, then hit enter. Now again I will drag this formula, so it is taking cantilever as 0 since nothing is specified over here. If I will specify 0.1 over here, it will take 0.1. If nothing is specified, it will take it as 0. So to start with our now shuttering formula, what we have seen in our PDF file is, first let us go and check. We have to take perimeter of the beam, complete perimeter. Now if I will go to beam number B11, it is an internal beam having slabs at both the sides. So our beam 11 is this example B2. So what we have to do is we have to deduct slab from both the sides. For both sides of the beam, we have to deduct slab depth on both the sides. So to begin with, first slab depth beam depth minus slab depth at one end plus beam depth minus slab depth at other side plus your beam bottom. This completes your perimeter. Now you have to multiply everything with your length. So I have multiplied this with length. So here our working gets over. Then multiply this with numbers as well. So here comes our shuttering quantity as 5.842. Now, if I want to work with our cantilever beam, this B52. So I will write here first B52, grade of concrete again M30, numbers is 1. Now let us go for the length. So here quick, length is 1.375. We will come here, length 1.375. The other two dimensions is 180 by 600. So 180 by 600. First of all, what I will do is I will drag my formula downwards. So it is saying 0, 0, 0. Now we have slab S1 at one end. So I have slab S1 here. I have chhajja at one end, but I don't have any number of these chhajjas. So let us assume that depth of this chhajja is 0.15. So I will specify 0.15 over here because I don't have any kind of slab depth. So what our formula will do, it will pick up 0.15. If I will specify it as 0.3, it will take as 0.3. So I'm assuming my chhajja is of 0.15 depth. So I have specified here as 0.15. So it has taken the formula. Okay. Now we have cantilever side as well, since our beam B52 is cantilever. So again, we have a chhajja over here. So again, I will specify 0.15 here. So you can see here, we are again getting depth of 0.15. Now, this formula is just for simply supported beam. Now, what if we have a cantilever beam? So we have to add this cantilever side as well. This side as well, we have to add in our formula because we have added this red inner side, we have added this outer side, and we have added this beam bottom as well. Now this one edge is left to be added in cantilever beam. So what we will do is, in this formula only, we will do plus beam depth minus depth of cantilever side into the width of the beam. So in this way, we complete the formula for cantilever beam. But I have to make my Excel sheet more formulated so that it will automatically take the formula as specified. If I will specify here it as cantilever beam, then AutoCAD should directly take formula of cantilever, and if I won't specify anything, it will take the formula for simply supported beam. So how we can do this? Here I will add if statement. If my this type is left as blank, then it will be taking this formula, and if it has specified as cantilever, then what it will do is it will take this complete formula, and also it will add our beam depth minus slab depth on the cantilever side into width of the beam, and now close this bracket. So it will automatically pick your formula. But one thing what we have missed is here we have not multiplied it with numbers. So again, multiply this with numbers and press enter. So now I will drag this formula. So you can see this value has not changed because we have specified cantilever over here. But if I will remove this cantilever comment, then our value has been changed to 1.69. And if I will specify this as cantilever, it will take the formula of cantilever shuttering. So I guess you are clear how our formula is working. Now, here I have also specified concrete. If we are working for shuttering, we can also work with concrete as well. So what I will do is, I will take numbers into length, into width, into depth. And here is what we got our concrete quantity. But again, I have specified my grade as M30 over here. So if I will specify my grade as M40 over here, my value of the concrete is not shifting in M40. So what we will do is, again, we will use an if command. If my this grade is equal to this grade, then you have to use this formula, or you have to keep it as 0. Now just we will freeze our cells. I don't want to move this column. I don't want to move this row. Then it is 0 now. Now it will again automatically shift in. Now it will shift in M40. It is showing its value because, okay, our formula has been shifted. We have to freeze this everything as well. So I will be freezing this all particular cells. Now it won't shift. I will be dragging it over here. Now you can see our concrete quantity is also shifting accordingly. Now if I will specify M60 over here, it will go in that particular tab. Now, once this working is done, we are set to work at a very high speed rate to achieve our target. For example, in this B14, I will be taking length of the beam 14 as 6.970. So B14, I will be specifying grade as, for example, M30. What was the length? 6.970. What are the dimensions of the beam? 200 by 600, 0.2 by 0.6. Now, as you can see, we have multiple slabs along each side, and we have beam as well. So while working, when this beam intersect, we don't have to deduct any kind of shuttering from here. When this beam will intersect, we don't have to deduct any shuttering from here. When this beam intersects, we don't have to subtract any shuttering over here. So what we can do is we can split our beam in multiple lengths. So for that, take distance of the beam from here to here. Or what I can do is, I have taken the complete length of the beam. I will simply, or wait, we can do like this. I will take the distance from this end to this end. It is 2.985. So I will take it as 2.985. Slab towards left is S1 and towards right is also S1. So I will specify S1, and I will just drag this complete formula. So your working is directly ready. And if I will add cantilever remark over here, you can see our shuttering quantity has been increased, since one side is increased in cantilever shuttering. But since it is not cantilever, I won't specify it as cantilever. Now again, to carry further, now this in this 160 where this beam intersects, we don't have to deduct anything from this distance, but slab S1 will be deducted for this width of 160. So what I will do is, now I will be taking length as 0.16. Beam dimension will remain same for width and depth. One side it will remain blank, and for other side it will be S1. Okay, so it has deducted only one time this 0.1. Now again beam 14 M30 for further distance from here to here. We have 1.095. I will be writing as 1.095. B and D will remain same. Now what we can see is at one end we have slab S5 and one end we have slab S1. So I will be specifying S5, S1. Rest all calculation is automated, so we don't have to look over there now. Again B14, M30 grade. Now again this beam width 0.16. So this length 0.16, 0.2, 0.6. We have slab S5 at one end. So I will be specifying S5. Now we don't have to look at the other end because this everything is automated and running automatically. Now again M30 for further portion from here, from this end to this end, delta X is 2.47. So I will be specifying as 2.47, 0.2, 0.6 will remain unchanged. At one end we have slab S5 and at the other end we have slab S6. So I will be specifying as S5, S6. You can see everything is formulated and keep changing accordingly. Now the last B14, that one offset of the beam we have to measure. So once we have automated our Excel sheet, we can work in depth for the quantity. If we have not automated it, we might have skipped this all small parts. We might have skipped because we have work pressure to complete everything on time. So we might have skipped this portion, we might have skipped this deduction, or we have deducted additionally this deduction. So by automating our Excel sheet, we can work in depth for the quantities because everything is calculated automatically. We just need to put our length over here. So for other example, this B62, what we will do is we will just measure our beam dimension, beam length. Okay, it is not giving, so I will be taking distance this end to this end. It is coming as 1 meter, so I will specify B62. For example, now this is coupling beam and grade is M61. Now length is 1 meter. Other two dimensions are 0.3 and 0.6. Now at one end we have S5, at other end we have S3. So we'll specify S5, S3, and I will just drag this formula down. So everything is automatically calculated. Now if I will add a remark over here, for example, cantilever. Now you can see our shuttering has been changed, but concrete remains unchanged, because whether the beam is cantilever or shuttering, concrete quantity will remain unchanged, but shuttering will keep on changing. So I will remove this comment from here, and you can see it has again changed to 1.25 square meter. So in this way, by using Vlookup and if statement, we can automate our Excel sheet and we can work very fast and very smoothly and accurately for working out with shuttering quantity of beams. So guys, I hope you have liked this video. So please do like, share and subscribe, and please be with us for more upcoming videos. Thank you very much.